We are trying to prove that when Sarah falls onto the sheet of tempered glass at the bottom of the train, it would break and she would fall to her death.
Oh God, please.
Our first step was finding the height and the weight of the actress. We found that she is 1.60 meters tall and weighs 53.97 kilograms. Next, we found the total distance she falls by estimating that the train car is 19.8 meters. We then subtracted 0.609 meters to account for the door she hangs on before she falls. Next, we subtracted her height, giving us a total distance of 17.6 meters. Next, we found the breaking point of glass by replicating the math from a test used in the glass industry, in which a 0.227 kilogram ball is dropped on a 1 square foot piece of glass from 2 meters. We used the equation velocity equals the square root of 2 times gravity times distance. Using this, we found that the square root of 2 times 9.8 times 2 equals 6.26 meters per second. Then we plugged this into the force equation, force equals velocity times mass divided by time. Using this, we found that the ball exerts a force of 14.2 newtons. We then divided this by 0.0001 meters squared to find the breaking point of tempered glass to be 142,000 newton meters squared. Next, we completed the same steps using the actress's weight and the total distance that she falls, which we calculated earlier. We plugged those numbers into the velocity equation and found that the square root of 2 times 9.8 times 17.6 equals 18.6 meters per second, giving us her speed as she falls. Next, we used the force equation, finding that 53.977 times 18.6 divided by 0.1 equals 10,039.722 newtons. Next, we estimated the area of impact to be 0.132 meters. We then divided her force by the area of impact to find the pressure she applied to the glass upon impact. We did this by dividing 10,039.722 by 0.132, which equaled 76,058.5 newton meters squared. We compared the amount of pressure it takes to break tempered glass to the pressure she applied after her fall and found the movie scene to be accurate. In conclusion, the pressure she applied to the glass was slightly more than half of the pressure it would take to break it, proving our original hypothesis to be wrong.